Rough seas in the Indian Ocean now threaten to end recovery of the ship from Flight 13 before it reaches port. This is SpaceX Daily, Episode 63. Recovery teams have called off towing operations for the 52-meter upper stage after 2 weeks of effort in the Indian Ocean. The ship completed re-entry and splashdown intact, yet worsening sea conditions prevented it from reaching port for inspection. Elon Musk stated that recovery efforts are not looking good right now. The outcome leaves open whether any hardware changes tested on this vehicle will appear on the next flight. This development follows the status reported yesterday on the same upper stage. While Starship recovery faces ocean setbacks, ground hardware at the pads continues to advance through controlled testing. Mechazilla at LC-39A performed load tests using ballast balls to simulate booster mass. The tests exercised the tower arms and structural interfaces ahead of future booster catch attempts. No flight hardware was involved in the sequence. Engineers recorded actuator response times and arm deflection under the applied loads. The data will feed into models that predict catch performance during actual super heavy booster returns. Results from the Florida tower will be cross-checked against Starbase data before the first catch attempt at the site. With Florida tower testing underway, Vandenberg continues its steady Falcon cadence. Booster B1063 completed its 27th flight carrying the NAOS mission from SLC-4E. The launch was recorded from the adjacent Fire Station 45. This flight adds to the booster's reuse record under the current Falcon 9 cadence. The booster has now flown more missions than most others in the active fleet. Range safety and telemetry data from the mission remain under review by SpaceX operations teams. A Falcon 9 mission remains on the schedule for a Saturday liftoff from Vandenberg. Weather and range constraints will determine the final window. Ground teams have completed final vehicle integration checks at SLC-4E. The mission continues the pattern of rapid pad turnarounds observed at the California site this year. Falcon hardware continues to deliver data even after its mission's end. NASA confirmed the Falcon 9 upper stage impacted the lunar surface at the predicted location and velocity. The event supplies fresh data on crater formation and regolith behavior from a known impactor. South Korean orbiter imagery captured the resulting crater for comparison with pre-impact views. The impact velocity reached several kilometers per second, consistent with orbital mechanics models. Analysts expect the crater morphology to refine future predictions of uncontrolled re-entries. While Falcon stages provide lunar science, SpaceX leadership continues to outline longer-term lunar plans. Elon Musk stated that lunar factories remain part of SpaceX's long-term architecture. The comment ties future in situ resource utilization to Starship landing and refueling milestones. No timeline or hardware details were provided. The statement aligns with earlier public remarks on using Starship to deliver industrial equipment to the lunar surface. Future missions would require demonstrated orbital refueling before sustained factory construction could begin. The same compute-heavy strategy now shaping long-term lunar ambitions is also drawing internal capital questions. One thing worth watching is SpaceX's xAI pivot now accounts for 82.7% of capital expenditures according to one analysis. The concentration raises questions about allocation across launch, Starlink, and other programs. Observers note the shift could affect timelines for hardware reuse and constellation growth if compute spending continues at this pace. The report examines supplier contracts and power infrastructure commitments tied to the expanded compute buildout. Observers on r/SpaceXA Lounge noted the official Terafab promotion video released by SpaceX, with Musk describing the Texas facility as the largest and most valuable building on Earth. The post included direct links to the SpaceX and Elon Musk accounts that posted the footage. Viewers highlighted the scale of the planned structure relative to existing industrial sites. Users discussed the recovery team's ongoing efforts to tow the Flight 13 ship through rough seas toward port. The thread referenced the 52-meter length of the upper stage and the 2-week duration of the towing attempt. Several users posted updates on sea conditions that ultimately led to the operation being abandoned. Community members shared footage of the Falcon 9 B1063 liftoff captured directly from the SLC-4 fire station. The video showed the booster's ascent profile from a vantage point immediately adjacent to the pad. Viewers noted the clarity of the plume and the timing of stage separation visible in the recording. On the AI front, Cursor indicated the SpaceX acquisition could close by the end of next week, with potential Grok branding on future products. The timeline aligns with earlier statements from Cursor leadership about finalizing terms. Product teams are already mapping branding changes and integration points for Grok models inside the editor. XAI CapEx is projected to reach top-tier levels, drawing attention to suppliers for the expanding cluster infrastructure. The analysis identifies key vendors for power systems, networking hardware, and cooling equipment required for the next phase of Colossus-scale builds. Spending growth is tied to training and inference workloads that support both XAI models and downstream SpaceX applications. SpaceX's $60 billion Cursor acquisition is reported as potentially finalizing next week. The deal would bring the AI code editor under the same corporate umbrella as XAI and Grok distribution channels. Integration planning includes possible rebranding of certain product lines to emphasize Grok capabilities for enterprise users. From an engineering standpoint, Mechazilla's recent load tests at LC-39A used ballast balls to apply controlled forces to the tower arms and structural interfaces. The approach isolates the mechanical behavior of the catch hardware from the variables of a live booster, allowing engineers to measure deflection, stress distribution, and actuator response under known loads. The tower must absorb the kinetic energy of a descending super heavy booster while maintaining positional accuracy within centimeters. Any excess compliance would risk misalignment during the final meters of descent. By substituting ballast for propellant mass and engines, the test removes combustion and guidance noise, revealing the pure structural margin of the arms and their mounting points. The data directly informs whether the current pin and latch geometry can tolerate the off-nominal trajectories expected in early catch attempts. If the measured stiffness exceeds predictions, the next design iteration can reduce actuator power or arm mass, lowering both cost and cycle time between flights. The ballast ball method also provides a repeatable baseline for comparing future tests that introduce dynamic motion or thermal gradients. In a real catch, the super heavy booster arrives with residual propellant, slosh, and varying thrust vector angles. The static test therefore serves as the zero-state reference against which those perturbations are later added. Engineers can now calculate the idiot index for the catch hardware, the ratio of finished tower cost to the raw steel, hydraulic fluid, and actuator components inside it, and identify which subsystems contribute the largest multiplier. Reducing that multiplier through iterative load testing is the direct path to cheaper, faster reuse of the booster stage. The LC-39A results will be cross-checked against Starbase tower data to confirm that both sites share the same structural performance envelope before the first attempted catch at the Florida pad. Watch for whether future tests add dynamic motion or thermal gradients to closer approximate flight conditions. Those additions would move the test campaign from pure structural validation toward integrated system verification, the final gate before a live super heavy booster attempts the tower catch. The sequence of static, dynamic, and then flight tests mirrors the same first principles progression used earlier in the Falcon 9 landing program. Before we go, the next Mechazilla tests at LC-39A may introduce dynamic motion to move closer to flight-like conditions. That's your SpaceX news for today. SPCX is trading at $133.11, up 16.3%. If the show saves you time, a rating or review on Apple Podcasts or Spotify genuinely helps new listeners find it. I'm Patrick in Vancouver. Thanks for listening. See you tomorrow. One more thing, if you liked today's episode, our sister show, First Principles Daily, is worth a spot in your feed. Reasoning from raw materials, not analogy, on the breakthroughs that actually cut cost. It's one of the NARA Network's daily briefings, all free at naranetwork.com. And on the website, every episode's visuals live in our free image gallery at naranetwork.com/gallery. Royalty-free under Creative Commons, download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.